Good afternoon, everybody. Good morning, depending on what part of the country you're actually in. My name's Stephen Crum. So today what we're going to be covering is querying with SSMS, just some basic fundamentals of how to do it, as well as some do's and don'ts to make sure that no problems arise by doing this. Several people always ask, is there alternate ways to query the Epicor system rather than the BAQ utility? Because you run into some scenarios of, hey, the BAQ doesn't let me do this, or hey, my query is taking forever to run. There are alternate ways to get into the Epicor data model, get the data that one would want, and then produce an Excel file or a report with it. So this will be going over how to use the Microsoft SQL Server Management Studio to do this as an alternative to the Epicor BAQ for the specific circumstances where this is needed. So your major target audience for this are your database administrators, your developers, your report writers are going to be your primary audiences for this. Other users can use this as long as they have the knowledge of how to use it. It is definitely not something that at a company one would give out to the general head of engineering or head of finance to do querying unless that was their specific role. Normally SSMS is kept local on the company's application server or their database server. You can deploy local clients, but it doesn't happen very often. So the first thing is, if people in here are new, I'm just going to assume that not everybody in here is a database administrator or has ever gone on to the application server for. So the database deployment is normally located in one of two areas based off of my experience with implementations. Either on a dedicated Epicor SQL server that is specific just for the Epicor database, or on the company's application server. So you might have an E10 app 01 and an E10 SQL 01. If you have an SQL 01, that would more than likely be where your Epicor SSMS application is deployed. If not, it is most likely on the application server. For your security on how to access it, it can be accessed in one of two different ways. You can use a direct Windows account, so the same account that you log into your normal Windows computer can be linked to the SQL server, and therefore you can just it will just automatically log you based off of domain security, or a local SQL account that exists. So an IT administrator could make you a specific login that has access. So take into account to talk with the network administrators or your database administrators to get access. And this is a key note. It is careful to consider the roles that are given to the individuals when they have access to the database. Certain roles allow users to do certain things. And that is what we'll cover on the next slide. So within this is just going over the basics of how to create a login, but what I want to focus specifically on is this section right here called the user mappings. User mappings and server roles are contained inside of the user mapping and the server role section. These same security roles are similar roles to what one would have in the server roles. These control aspects of whether or not the user is an administrator, can push data into the server, can read the data. If you are just going in there, say you've been given access and all you're doing is trying to query some random data, I would suggest not having anything more than the data reader roles on your account. It means that you're able to do queries, you can look at the tables, but from a database standpoint, you won't be able to accidentally delete something or update anything. Just in case anybody ever tells you updating your Epicor data model through the backend SQL tables is an absolute no-no, just don't do it. It runs into large problems if you do. So if you're not an admin at the company, I know some of you in here are probably IT people, so you have the keys to the kingdom, so to speak. So you don't really have to worry about this. But if you're going to give access out to maybe some subordinates in your IT department to help query data or write reports, having just the data reader roles as well as the respective databases the user needs access to selected tends to be the best practice. So we're going to cover just I have some slides in here just that go over some basic navigation. Again, I don't know how many people in here are the admins and how many people in here, this is the first time they're seeing this. So I just want to make sure people know how to get from point A to point B. The second half of this past the slideshow is going to be all practical use case examples and going over everything. So everybody will be able to see how it works and be able to ask plenty of questions about how to do this or how to do that. So when you open the program up and after you've connected, you'll have the ability to select a new query, which will open up a query menu similar to this. It's completely blank. It has no data in it. There is underneath, once you create a new query, you have what is your server selection. So most of you probably have a test, a pilot, and a production environment. So selecting this dropdown will allow you to change what environment the query is actively running against. And then you have your execution button, which will run your query. Alternative, like most computer programs, you can execute by pressing the function 5 key on your keyboard if you have it. So querying basics, since most people have in here probably have run a BAQ at least once in your lifetime of Epicor. And if you haven't, you're going to learn something a little bit new. Inside the main screen of the business activity query, where you would specify the name of your BAQ, it produces a section which is the query output. So as you drag and drop the tables and join them and add your fields, on the main page of the BAQ, it begins to write the code behind the BAQ. And this is all written in SQL format. As long as you have not used any calculated fields, because the way that Epicor handles calculated fields is a little bit different, or you haven't added any custom user-defined fields, like adding a new field, an _C field to the table, you can actually copy that query that you built in your BAQ and paste it directly into the SQL Server Management Studio and execute it, and it will run. It is a fully justified set of code written in SQL. It's just the way that it handles UD fields and calculated fields are unique to how Epicor works, so they wouldn't import into SSMS correctly. So when you get onto the server, you're going to be noticing two table sets. ERP and ICE are the two table sets that you'll be noticing. ERP tables, these are your main accounts. Okay. just so everybody knows, I do have my cell phone up that can see the chat, and so Manny, I will go over your question in a little bit. But I'm pretty sure other people like Nick and a few others might be able to help govern the chat if you have any questions. So they'll help you out with that. So ERP tables are your base main product tables. These include your part table, your order head, your job head, tables that are your main functional tables. The ICE tables are your system tables. These can control user-defined tables, such as the UD01, 02, 101, as well as system process tables like the system agent, system monitor, and other items. So knowing which one I would say when you're developing queries, whether it's a BAQ or it's querying directly through SSMS, 90% of the time you're going to be querying directly against ERP tables. So what makes up an SSMS query? Basically, in the standard query, there are 4 portions to it: the select statement, the from statement, the where clause, and the order by clause. And these are constructed in the order that I have written them. It is in a random order. So your select statement at the beginning contains all of your field information, calculated fields, limiter statements such as the top clause or distinct clause. The from statement contains your table joins, subqueries, unions, CTEs. Where clauses are at the end, which contain the ability to isolate specific data conditions for, say, the only return me purchased parts or manufactured parts. They can be static values, dynamic values, or calculated conditions. Where clauses can be put at 2 levels. They can either be put at a table level or they could be put at a global query level, and we'll go over examples of that. Finally, there is the order by clause. This controls your sort order. So if you wanted items ordered by part number, earliest date to latest date. And it's important to note that the where clause and order by clauses are optional. You do not have to include them if you do not need them. So in the slideshow, I just wanted to include a basic query example that contained all the elements. We're going to kind of go through some scenarios of a lot of things that customers just standardly ask for. So this is just a really basic one to give you some information in case you forget some items. So select top 100 star is the beginning of your select statement. What this essentially translates into is return to me the top 100 rows of data that this query returns, and star just means return all the columns that it finds in the appropriate tables. From ERP part T1 with no lock. ERP part is return it from the part table. T1 is a table alias, and we'll get into why table aliases are important on the next slide. With no lock is another good housekeeping command when you're writing SQL statements. It acts as a bit of protection to the query. I have a whole whole slide portion on what it does specifically, and we'll cover that next. On T1 company equals T2 company. So when we're getting into the left outer join into ERP part plant T2. So we're going to join the part to the part plant. You might have noticed this in a BAQ tool. This joins automatically. What we're doing here is conducting the join by writing T1 company equals T2 company, T1 part number equals T2 part number. Now, as a rule of thumb and best practice for writing anything, whether or not it's a BAQ or a custom query, always include the company join in every single query that you do when joining between two tables. Even if you are a single company site, always include the company. And then when applicable, include the plant as a joining condition as well. It protects everything if you're a multi-company or multi-site environment. It also just makes it so the queries will run more efficiently. Where T1.typecode equals P, this essentially means give me only cases where the top level part is a purchase part. And order by part number descending. So this is going to order by the part number in a descending order. So in the previous example, the no lock statement is used. What this essentially says in layman's terms is it says don't lock the database table when conducting a query. It leaves the possibility, if you've never heard the term of a dirty row being queried, but with how fast Epicor commits data to the database, this doesn't tend to arise very often. What it prevents is the system going into competition of getting of locking a user out. I'm sure everybody probably has seen the obligatory message object. A row has been modified by another user. What a no lock helps prevent is it pretty much makes it so that the SSMS query that's running on the SQL server is not going to contest any other process for that table. It just is good housekeeping. And making sure that you don't accidentally lock something up if the user's trying to get into it. Table aliasing is also a very helpful item. In the previous examples, we used T1 and T2 to indicate the part and the part plant table. If we didn't do that, we would run into these different scenarios. With the aliasing, if we wanted to say, query the part field from the part master, we'd have to write T1.part number with the aliasing of T1. If we didn't do that, we'd have to write ERP.part number to query the field. I don't know about you, but writing a short script is a lot better than writing all of that. Now, I just use T1, T2, T3 as my aliasing syntax for every query that I make. It helps me keep track of how many tables I've added into the SQL statement. But if you want to, you can use any syntax that you want. If you want to call the part table P, the part plant table PP, the job table job. If you want to start naming them after sports kids or your dogs, you can do that too. The system doesn't care. So some of the additional items that we're going to be going over and some helpful commands is we're going to be covering an example that uses outer applies, which is another way of conducting subqueries in tables in case you're interested in knowing specific pieces of data. Link tables, I'm really not going to have a use case example for this one just because I haven't spun up a secondary system to do a link table example. But what link tables allow you to do is if you were in the middle of conducting a data migration, I know some people on this call I have used this for, and you're comparing a legacy system to your current Epicor system, and as long as the legacy system's a SQL database, you can conduct a join between the legacy database and your Epicor database. So if you were interested in seeing how methods have changed between the old system and the new system, you could cross-compare the legacy system's bill of operations table to Epicor's bill of operation table and start cross-comparing them. As well as if you are writing items inside of SSMS to pull data, you can, if you are on-prem, you can import this data directly in this query that you've written directly into an Epicor SSRS report, provided some additional setup is done, and be able to run SSRS reports that query the database directly. I've had scenarios for complex reports that have been handled through the methodology. So we're going to go through a few, we're going to jump out of this and we're going to run through a few working examples on different items that I tend to get asked questions a lot, how to do this, how to do that. And then once we run through the examples, if people have any questions about what I'm doing, as I said earlier, I have the chat open, and if somebody has a question about what is this, what is that, if I can answer it quickly in the flow, I'll answer it. If not, I'm gonna hopefully wrap these examples up by about 12:45, so there'll be 15 minutes of Q&A. Oh, I'm going to switch over to a virtual machine. Now, this is just an Epicor 10 training environment virtual machine that we have spun up. This doesn't really matter for what version of Epicor on. If you're on Epicor 10.2, 10.1, the SQL is still the same. Microsoft has not changed really any of their syntax for querying in 20 years, and the way that Epicor deploys the databases is fairly standard. So to start off with, we'll do a basic example of, let's just go in and query just the part master to start off with. So our select star from ERP.part, and as we did in the example, we aliased it to T1. And what we can then do is we can run this, and of course, we get every field that's in the part master. Say if we only wanted to see just the part number and the part description, as well as I'm going to keep the company in here. If we add in the fields, of course, separating everything by commas, we run our execution, we just get the 3 fields that we've asked for. Now, because this is the training environment, and as you all know, the training environment has all those extra companies that we're going to get rid of Epic. We're going to filter this down specifically to where T1.company equals Epic. Now, we need to put this into, since this is a string field, we need to put this into single quotes, or else the system won't know what to do. And in most cases, SQL Studio is not going to enforce any type of case sensitivity, so you don't have to worry about matching the case text in I'd say 80% of scenarios. So now we're limited down to just the part table for Epic 06. Now, let's add in another table that might not be a standard that you might join in to do. Let's check for the sales orders that have been cut for these part numbers. So we'll conduct a left outer join. ERP dot order, well, left outer join, ERP dot order head. Now, as you've probably seen, the system's trying to complete my fields for me. This is the IntelliSense inside of the SQL Studio, it kind of starts helping you fill in the ends of statements. So if you're trying to query fields, you're trying to add tables, it adds in a speed lookup for you. If this is not active inside your SQL Studio, there is a couple steps to turn it on through just going through tools and enabling it. I would say 99% of the time it comes passively enabled. Sometimes it's disabled, and when querying some older styled systems, if you say had a like were a legacy Epicor customer and your system was a very old SQL system, you might run into some problems with the IntelliSense not working the right way. We're going to add the order detail table and alias it as T2. And we're going to join between, and we're going to say on T1.company equals T2.company, as this is the most important first join, and T1.partnum equals T2.part. Now we'll add a couple fields in from the order detail. So we'll add in the part number field just so we know that we're getting a positive match. We'll get the order number and we'll get the order line. And we'll execute that. Now what you can see are items that are returning nulls. A null in this sense would be a failed to find, meaning that this part was never ordered on a sales order. If we have positive values like this component C1A, we can see it's been ordered on order 5366. Now, if we were concerned to only see the order, the part numbers that have ever been done on orders, it's just a matter of changing this join. If we want to do that, we can switch this join from a left outer join to an inner join, re-execute the same query, and now we're only seeing the parts that have had orders for them. So keeping in mind your join types is rather important. So I'm going to go one step further and change this query up a little bit and start migrating us towards our recursive BOM, because I'm pretty sure a lot of people in here, being able to see a recursive BOM is of interest to everybody. So I want to have enough time to talk about that. The next example that we're going to cover is what is going to utilize an outer apply. So I'm just going to type this. Oh, I'm going to type this a little bit quickly just to get it into the next step. Let's see. So I'm just going to comment this out really quickly. So we're going to query data from the job operation table. Now, with our job operation table, and I'm going to filter this down just to say where T1.company equals 6. A common question that people get asked in a workflow is, and actually switch this over to the job head, is what operation is my job currently at? Give me a single row of the job number and tell me where in the workflow all of my jobs are at. Are they at assembly? Are they at cutting, etc.? And there's a couple different ways to handle that, but one of which is using the outer apply. And an outer apply starts off just with the statement of outer apply, and then you have to open up parentheses. Essentially, an outer apply is essentially an outer apply is a query inside of a query. It's similar to a subquery, but different in a few ways in the fact that it doesn't use normal joins, it uses where clauses to join in. So it can be specified a little bit. You can go through a couple more levels of specification with how it works. So just like a normal query, you still have to have a select statement and a from statement inside that. And I'll fill in the select statement after I build the from statement. So we're going to pull our job operation table. So erp.jobOper. And as I said earlier, you don't have to necessarily use these T1s. I can call this JO. And I can say where jo.company equals T1.company and jo.jobnom equals T1.jobnom and jo.opComplete equal 1. So that is telling our query that we only care about the uncompleted operations. Then I can come into here and add an order by clause and say order by T1, order by jo.company, comma jo.jobnom, comma jo.opersequence. Now, just for the sake of things, I'm just going to double check that I spelled something right up there. I messed that up. So now we're saying pull the job operation table based off of this and whether or not the operation and only give me the ones that aren't complete. So within here, I can say select top one. O.opsequence as lowest op. And then and then on the outside of this outer apply, outside the parentheses, I have to call this query something. I have to name. I'm going to call this current op. So now what I can do is I can say t1.jobnom and then say current op.lowest op and run this. So as you can see, we're seeing the lowest operation that's not completed. Now these nulls are probably from jobs that are complete, that have actually run through completely. They're most likely completed and closed jobs. But we can see what the lowest operation is on these jobs that hasn't been started. You can add in additional filters in here to work on if you were concerned about multi-level assembly. If you had the case that you're running multi-level assemblies and you wanted to know where each assembly was at in its process through a couple changes and some grouping clauses in here, you could then create it where I have job number X and it produces 5 rows and it tells me that assembly 0 is at op 20, assembly 1 is at op 40, assembly 3 is at op 10. And you can have that type of information display. The outer apply query is useful for pulling specific sets of data that might gum up your query if you want a particular piece of information. The nice thing about the outer apply is that now that I've queried this, this gives me a table name with fields, and I can use it to join into other tables. So if I wanted to then go in and just for a quick final step, I wanted to go into the job operation table and actually figure out what operation that was. I can come in and say on t1.company equals t3.company and t1.company equals t1.job number equals t3.job number, and op dot lowest op equals t3 dot offer sequence. And then if I come up and add this data into here for the, say, op description, it is now going in and telling me what I have. So that is an example of using the outer apply function to go in and query a particular data point out of a table that could produce many rows. Now, the final example, which is really going to be a general walkthrough about the elements that make it up and showing how it works. If people have more questions about it, I'm happy to field emails on it. Any code that I've written in here, if anybody wants it, I'm more than happy to provide it. So the final example is a recursive bill of materials table. Now, Epicor ships with a default BOM listing report. Other customers might find that having a recursive BOM because they might want additional pieces of information in their report, linking it possibly to related to operations to see what operations raw materials are getting called at within methods, etc. This is an example of a recursive BOM. So a recursive BOM, to run it, requires what is known as a CTE, or a common table expression. It's essentially a report that gets looped through, and it starts with an anchor query. And the thing to know about a CTE is that every single field that you put into a common table expression that then links to a union, which is the second part of this query, is significant. When writing recursive BOMs, what's inside the number of columns in a CTE must match the number of columns that are inside of the union, or else it fails to do so. So sometimes you have to put placeholders. Another item that is important within CTEs and unions are making sure that the system understands data types being equivalent to each other. If you can't compare string to integer, you have to make sure that even if the field always is a integer field, a string field, but you only ever put numbers in it, you have to declare it as being an integer. Or else the system will proceed to bark at you and say that I don't like this. So in our initial portion, which is the CTE, we've called out the field names: company, assembly, material sequence, the part number, the description, type codes, UOMs, quantity pairs, estimated scraps, revisions, top level part numbers, etc. Now, the order in which these fields are written and the order in which these labels are written are actually significant. So the fact that I write company first means that that's my company field. If I call this material sequence and put material sequence as the second value up here, this field right here that I say assembly sequence would now be the material sequence, and the value that it would get inside of it would be 0. So positions and how you write the fields that you want and how you write the fields up here is important. Inside the from statement, it is a basic from statement to go through and join between the part table to the revs to the bill of materials, and then finding out some additional information about the part revision of the material component that's being built. Hence the reason for outer apply getting built in here, just to pull only one particular bit of information from the part rev table at the material level. Because what we're going to have with the recursive BOM is every time it encounters a manufactured part, it will loop through, it will want to conduct a loop through the table again. Our union all conducts the loop. So what is going to happen is this query up here is going to execute, and then what is going to happen in the subquery is for each time it encounters a manufactured part that has a valid method for it, it is going to proceed to loop through. And it's going to do it over and over and over again until it runs out of parts that it encounters for manufactured parts. I know that this is a 10,000-foot overview. If people need detailed specifics on how this all works, I'm happy to go into further detail. But what you see, and I've only plugged in a single part number to run this. I could run this wide open. I just don't want this system to this query to go through and produce like 50,000 rows of data in it. I only want it to look at a particular example. What we can see here is assembly level 0. So this is our top level assembly and what's required to build it. When we get down into assembly, recursive 1s and 2s, these are first level items, which means that they're required, which means that we had an item in the top level assembly that's a manufactured part, and it requires additional pieces to build it. After, when we get into 2s, that is a component inside of a component. So what this query will tell you is how deep down the rabbit hole are we going, and it's always going to link back to the parent assembly. So this part number MLQ25 right here, which is a frame, is a manufactured part. It requires these two casings to build it. However, this support bar right here, as we can see right here, at assembly level 2 requires this round bar stock to build it. As we can see that it hasn't gone down to a third level in any cases, is that inside of building this MLQ25, this is as far down the rabbit hole as we have to go. And it terminates right there. What you could do from this then is produce you could then produce reports in SSRS, or a really helpful thing is you can just right-click copy with headers from your export grid down here and paste it right into Microsoft Excel, and everything will go in cleanly in case somebody needed to do additional data analysis. I know that we're kind of running up against the wire right now, and I want to have enough time for people to ask questions. Again, if anybody wants these query samples sent over to them, I'm more than happy to provide them. So with that, I'll open it up for questions for the next 10 minutes if anybody has any questions.
I just want to say, Stephen, that I'm probably preaching to the choir here, but you made a great point when you created the query for only one part number here, because if you left it open-ended, we all know what could happen with a query and how much it could slow down the system. So great point that you just made. And again, I am probably preaching to the choir knowing the level of talent on this call, but great point there, Steve.
Yeah, so normally when testing queries out, it's important to practice them in testing environments with limiters on them. especially if you're messing with tables like the part tran table, everybody, or heaven forbids the tran GLC table. You want to go through and put limiters on until you know it's working the right way.
Exactly.
Once you know it's working the right way, then it's kind of free to open up the floodgates.
Right.
But you might run into scenarios when you're pushing these out to reports that you might want to put specific criteria in them because you know that they can react. Recursive bomb queries, if I'm running them directly on here, if I know exactly what they're going to do, I don't have a problem running them wide open. But normally, if I was going to deploy this to an end user report with extra data in it, I would probably put a criteria that says, please tell me the part and revision that you want me to run for.
Great.
So
we
Kevin,
have. Well, I was going to say, go ahead.
So it looks like in the chat, everybody wants the queries. So I'll package these up and send them to you so then you can send them out with the PowerPoint slides.
Sounds good. And we have Mr. Henry Burke with a question right now. He's got his hand raised.
Yeah, I'm sorry I couldn't type in the chat, but I was curious about both the outer apply and the CTE. If you would share what the lifespan of each of those is and their scope of existence.
So the CTEs, if you're talking about how long would the usability of that function be from a longevity standpoint, CTEs have been around for I don't know, probably from back when I was still in high school. They've been around for about the past 15, 20 years. Every version of Epicor's business activity queries supports CTs and unions. I don't foresee Microsoft getting rid of them unless there's a complete overhaul. As long as SQL is a programming language, and Microsoft doesn't seem to be getting away from that.
I guess I meant in memory.
Oh, in memory. Okay.
When you invoke those, what is the scope of and duration of their existence? They're different from obviously like SQL views.
They only exist at the time that the query runs. They don't persist into a secondary table if you were to say do a creation of a view. As Aaron chimed in on his in the chat, CTs and our replies only exist in the scope of the queries. They don't persist.
Okay, I guess I missed something when you were kind of moving around in the query. I thought you were actually invoking the outer apply sort of in advance, and so I guess I wondered if its lifespan was greater than the extent of the execution.
No, they're just different querying utilities inside the current query that I'm calling.
Okay,
and they can be written whenever they are needed. So I saw that, and I know I'm going to butcher this name, Kostadin. I hate to say that I'm going to butcher it, and I apologize. So yes, there are multiple ways to look at tables in Epicor to see everything that you have. If I come over on the Object Explorer on the left-hand side, I can expand the tables under ERP10 train. You probably have tables that are like, you might have database called ERP10 live test. You can expand that and expand the tables and see the names of all the tables. And if you're interested in seeing the data that might be contained in one of those tables, I'm just going to go scroll down to find something that's going to have data in it. Like the labor detail, you can right click on the table and say select top 1,000 rows and get a sample of data from that table. Another alternative is if you are in Epicor, there is a program in Epicor called the Data Dictionary. And that has all of the tables that exist inside of Epicor, as well as a short little blurb that has information about what the table's used for. Manny, I saw your question, but I believe that your question is specifically in scope of Profit 21 and not Epicor 10. And feel free to unmute yourself if you want to talk.
Any other questions?
So while I wait for Manny to chime in, I'll give one other piece of information out here, just for all of you, or just for everybody who might be a report writer on here. Inside your report database, what you've probably said to yourself when writing reports is, how the heck do I know the data that's going into my Epicor SSRS report and is a field that I need inside the current scope of the data that's included? If you run an Epicor report like the AR invoice and you tell it to, in the report options, archive it for a day and go to the report and go on to SSMS and expand a node, you'll probably have a node called ERP10 reports. If you expand that node and expand the tables inside of it, and I don't have any because I haven't wrote any, but you'll have a section here for the file tables. What it actually will do is it will put in for every table that is casting data over to that Epicor SSRS report, you will see a table entry, say like invoice head underscore a series of numbers, which is the GUID. If you go into that object and right-click open with, right-click select top 1,000 rows, you will actually see all the data that's inside that table, as well as what the field names are. Just in case you're like, I swear to gosh that there's supposed to be data in this field. Why is there no data? And then you can figure out whether or not data truly is in that field. Just a little extra bit of knowledge for anybody in here who's a report writer and has hit the wall of how the heck do I know whether or not a field's giving me data when it should be. So Manny, in terms of Profit 21, unfortunately, I'm not well versed on Profit 21, so I wouldn't be able to give you a good answer on that question about what table holds that assembly decoder template and segments.
Okay, we are close to the 1 o'clock time. Any other questions? If not, I sent what looks like Enid has a question. Outer apply versus join. I think she said, Steve, versus join.
Okay, so a join, like I have in my example that I did right here, your left outer joins and your inner joins, as seen above here, are more straightforward. It acts in the scope of the first level of the query. So you kind of have to think of it as layers. So when I join between the part and the order detail, it's a straight join in that level of the query. So it goes from the part to the order detail, gives me all that information. Joining the two tables together. An outer apply is essentially a query inside of a query. So what I'm writing here is I'm going down one level from the top level query and putting it's essentially a different version of a subquery. And what I use the outer applies for is to get oddly particular data points. If I know that I need to get, let's just take an easy example, the part tran table, everybody's familiar with that. If I want to know the last date that a part was transacted, I know that a part could be transacted in the part tran table 1,000 times. I would use an outer apply, or I would write myself a subquery to only pull me the last date that that part was transacted. So therefore, in my top level query that only has the part table, I see one row of data per part number, but I'm going into a table and selecting a singular row that could have resulted in minis. I hope that that answers your question.